welcome to my channel. In this video, I'm going to talk about MySQL Master Master Replication over SSL or the encrypted channels. Let's take a quick look at what we are going to be looking at or doing today. First, we will configure the replication on both master and the slave servers. When I say master and slave, we will be doing the master master replication, but both of the masters are the slaves of each other. So we will configure master and slave on both sides. That becomes the master-master replication. Then we will create the CA certs to be used with the MySQL replication. The CA is actually going to be the trusted party which will sign the certificates for both the masters. We will create and copy the certificates for both servers. Then we will configure the slave permissions with the SSL as the requirement. We will then configure the MySQL to use the SSL and the certs. And finally, we will configure the replication and actually start the slave on both servers. And of course, as the last step, we are going to validate to ensure that the replication is properly working. Before jumping into the hands-on configuration of the replication, I wanted to take a moment to look and discuss the different options and configuration parameters that we will be using to configure the replication. I have the two servers configurations side by side so we can, look at it as well as talk about the different options. The first option is the server ID. The server ID has to be specified in order to enable the binary logging, which is really the basis of replication. The range for the server ID is 1 through 2 to the power 32 minus 1. Replicate same server ID is the next option. This setting is used to prevent infinite loops caused by the circular replication. By setting it to 0, we specifically tell the slave to skip events with its own server ID. This setting is turned off by default, but I like to explicitly specify this option. The next option is the auto increment. This variable controls the interval between the successive column values. Notice that we have the auto increment set to 2 in this case, which is also the number of masters. So this number is recommended that you set this to the number of masters. So if we have n number of masters in the replication group, then you would set this to n. The next option is the auto increment offset. This setting determines the starting point for the auto increment column values. The default value for the auto increment offset is 1. The auto increment and the auto increment offset are really used together to avoid a situation when both the masters insert a new record into the database at the same time. In such a scenario, both the masters may end up using the same auto increment ID. In order to avoid that situation, the auto increment and the auto increment offset are used to ensure that such a collision does not occur. The auto increment should be chosen as the number of masters in the replication group, as I mentioned earlier, and the auto increment offset should be chosen as the count representing the specific master. For example, in the server A, we have the auto increment offset set to 1, which means the first server. In the second server, the server B, we have the auto increment offset set to 2. Let's move on with the other settings. So the rest of the configurations are really related to the log files and the binary logging information. The relay log is a set of log files created by slave during the replication. The events are read from the master's binary log and are written to the slave's relay log. They are then executed on the slave system. The relay log by default are named based on the hostname, and therefore it can break the replication if the hostname changes, which is why I like to specifically define the name of the relay log file explicitly so that the change in the hostname does not break the replication. The relay log index keeps a list of the last relay log file and also defaults to the hostname-relay-bin.index format of the file naming. So I like to specify them explicitly and recommend the same. Log error, as the name suggests, is the location of the error log file. The master info file is the file in which the slave keeps the information about the master. Once we configure the replication master or specify the slave about the master server, it stores that information in the master info file. Relay log info file is the name of the file in which the slave keeps the information about the relay logs. Log bin is the option that actually turns the binary logging on. It also specifies the location and the name of the binary log file. Binary logging is actually, like I said, the basis of replication. The server essentially logs all these statements that make any changes to the data into the binary log, and again, when the slave server reads through and executes them on the slave server, that's how the replication works. Once again, the log bin option without the server ID will cause the server to not start. So you should be really careful about the log bin and the server ID options being tied together. Now let's quickly go through the rest of the steps that we will perform in order to configure the replication. The next step is to generate the CA certificates that will be used to sign these certificates for the individual MySQL servers. We will use the OpenSSL commands as shown in the slide to generate the private key and the actual CA cert. Once we have the CA created, we will generate the certificates for the servers once again using the OpenSSL commands. One thing to note is that the CA and each of the MySQL servers has to have the unique common name in order for this to work. So when we generate these certificates, we need to be mindful of the common names. Once the certificates are generated, a slave user will be created with the replication slave role and the SSL requirement enforced. We will then update the MySQL configuration file with the SSL option and the path to the CA, as well as the server certs and the key files for each of the MySQL servers. The next step after configuring the MySQL configuration file is to get the position from which we want to continue the replication. If you are dealing with a brand new database and it is not in use, you can just get the position with the Ssl master status and note the log position and the log file name, and then you can just start or continue the replication from there. However, if you are trying to replicate an existing database, you can use the flush tables with the read log command and note the status and dump the MySQL database. Once the database is dumped, unlock the table so that the server can go back to normal operation while you restore the database into the slave. Once you have the starting position, it doesn't matter that the server goes back to operation and makes the changes. When you specify the log position, the new slave will actually replicate any changes that were made after that point. Finally, we will issue the change master command to configure replication and then start the slave. We then start the replication on the other side and essentially have a two-way master-slave configuration, which essentially is the master-master replication. Since we have the SSL encryption enabled and enforced, we will actually have the master-master replication over encrypted channels. Once we have everything in place and started the slave and all that fun stuff, we will validate the replication. Some quick tips though. If SCLinux is enabled, you might need to restore the SCLinux context to the cert files. I'm not going to cover that in this video just to keep this video simple. The next quick tip is the show variables like %SSL% to check if SSL is enabled. We will do that in our hands-on part of the tutorial. And then finally, we can use the TCP dump or encrypt to troubleshoot any SSL handshake issues we might have and or to validate the encryption. One last thing is that between the two MySQL servers, you may have firewall. If you have firewall D running, this is how you can configure the firewall D to allow the 3306 or the MySQL port to the slave on both sides. I will, once again, for this video tutorial, just disable the firewall D. And that's it. I know you have been waiting for this, so let's jump into action. I've got two machines here with the CentOS Linux 7.6, that's the CentOS 7.2.1, which we will consider to be the server A, and then I have the 2.2, which we will consider to be the server B. In order to get started with the MySQL replication, let's go ahead and install the MariaDB server first. So yum install MariaDB-server. Press yes, and I'll go ahead and do the same on the next server. go. Clear screen. In the older version of the MySQL servers, the MySQL main configuration used to be etc my.cnf, but the newer MySQL servers seem to have the my.cnf and then the my.cnf.d directory, which has other MySQL subconfiguration files. For our purposes, in order to configure replication, we will be working on the my.cnf.d/server.cnf file. There. We will mostly be working on the MySQL D section. As we talked about the different options in our slide, let's go ahead and configure those. We will first start with the server-id. We will set this to 1. The replicate, same server ID, set that to 0. Auto increment dash increment equals 2, set that to 2. Make it a little readable. Auto increment dash offset, we will set that to 1. Then the relay dash log equals, we will say var lib MySQL server, this one is A, so we'll say server A dash relay dash bin. So relay dash log dash index, we will call this var lib MySQL server A dash relay dash bin dot index. Just try to name them, in a way that when you look at the files, you can tell what these files are. Log error, we will specify that to be var log MySQL MySQL.error. Then we'll specify the master info file that, let's say, var lib MySQL and then MySQL-master.info. And we'll have the relay-log-info-file, set that to var lib MySQL-server A-relay-log.info. Let me actually put this together with this guy here. Separate out these sections. Log-bin, we will set that to var lib MySQL/server A-bin. So that's all the configuration that is needed to enable the binary logging on the server. So we'll go ahead and copy this, save this here onto the next server. Let me clear this screen. vi@c my.cnf.d server.conf, and onto the MySQL D section. Go ahead and paste this. So the server ID, we want to set that to 2 because the server ID has to be unique. We don't want to replicate the same server ID. Auto increment, we are still going to set that to 2 as we talked earlier. It's the total number of servers in the group. The auto increment offset, however, is the count of the server. So this is the second server, so we will set that to 2. Then we will search for server A and then replace that with server B in all occurrence. That's it. So let's go ahead and save that. Back to the server A, let's go ahead and restart MariaDB. Do the same thing on this server. Systemctl restart MariaDB. That way we at least validate that the MySQL, whatever changes we made, have not introduced any errors or any problems. So the MySQL seems to be running, or the MariaDB seems to be running, so we should be good with our configuration. Same thing here. All right, so far so good. Now back to the first server. We will go ahead and start working on our certificates. Let's create a directory first where we can store all our certificates. Since the home directory of the MySQL is most likely varlib MySQL, as we can see here. Let's go ahead and create a directory in there. Let me see what it has. Okay, let's just create a directory one step before that. So mkdir varlib MySQL-search. So we'll create that directory. Let's go into that directory. And now we will generate the CA cert, the server certs for the server A or this server. And then we can either generate the certificate for the server B on this same server, or we can just generate on the other server. It doesn't really matter as long as you provide the separate or the unique common name. It doesn't really matter where you generate the certificates. So we will just go ahead and generate all these certs needed in this box. Alright, so in order to generate the CA cert, we will start with OpenSSL gen RSA 2048. Use the 2048 bits. And the file name, we will go ahead and set that to MySQL Ca key.pem. Okay, that's the key file for the CA. Now we are going to use that SSL, OpenSSL request, new request, x509 nodes dash days. We have 3600. Just be mindful of the number of days we have here is 3600. So the certificate or the CA cert is going to expire after 3600 days. Just need to be mindful of that. You could actually be using a trusted authority signed certificate as well if you wanted to. So days 3600 minus key, and the key is going to be the key that we generated here. Paste that, and then we're going to output MySQL Ca-cert.pem. Alright, so for this tutorial, I'm just going to leave everything at default, but you could put that country name, the state province name, the locality name, and everything to your liking. The most important thing, however, is the common name. So for this, I'm going to say MySQL Replication Ca. Everything else is default. Now if I look at the directory, I've got the MySQL Ca cert and I've got the MySQL Ca key. So we are basically done with creating the CA for the replication. The next step is to create certificates for both these servers. We will use the same OpenSSL command, OpenSSL request new key, use the RSA 2048 bits keys, same 3600 nodes, and then key out, which basically means create the key also, server a-key.pem, and then out is the server a-req.pem. Basically, with this command, what we're doing is we're generating the new private key named the server a-key.pem, and then we're outputting the server signing request, the server a-req.pem file using that key. The same thing again. Organization name, we'll leave everything at default but the common name. So for the common name, I'm going to say CentOS 7-221, or we could have set the server A. So that's that. So we have the server A certificate request. Now what we are going to do is we're going to use the CA certs and the keys to sign this request and actually generate the server A certificate. Again, OpenSSL x509 request, take the server A request in and expire in 3600 days. Use the CA MySQL Ca-cert.pem, and then the CA key is going to be MySQL Ca key.pem. We'll set the serial to 01 and then output the server a-cert.pem. Okay, looks like I messed up a little bit. OpenSSL x509-req in server A requires this 3600 CA. We specified the CA. The CA key the set Ssl and then out server A dash cert pem. Okay, let me check what the unknown option Ca key. Okay, looking at the error helps, so I messed up the spelling. The K is supposed to be lowercase. There we go. So now we have the server A certificate, the server A key, and then the request file is no longer needed, but we can leave it there. So now let's go ahead and do the same thing for the server B. So we're going to create the server B key, server B request, and the same thing here. And the common name we are going to say CentOS 7-22. That's it. So now we have the server B key and the server B request file. Now let's go ahead and actually sign that with the CA. We're going to use the server B request and then output the server B cert file. And that is it. So we have the CA cert, we have the server A cert in the keys, we have the server B cert in the keys. Let's go ahead and copy this directory onto the next server. In order to do that, let me quickly install rsync on both the machines actually. Yum install rsync. Okay. Now I am going to rsync pzarv varlib mysql dash search to let me get the IP address. So the IP address is 140 here. Var lib mysql dash search. So let's go ahead and sync the files over. Okay. Let's validate. We have the files var lib mysql dash search. And we have all the files on the server B. That's great. Now on to the next step. We are going to configure the user that we will require for the replication. So basically we create a user with the replication slave role on both the servers. Let's start with server A. Going to MySQL, we will say grant replication slave on star. We want the slave to be able to replicate everything. We'll keep it simple, slave user at, and we're going to restrict that to this IP address 140 identified by, and I'm going to put a simple complicated password, and then we are going to enforce the SSL requirement. So by saying require SSL, this user is required to have SSL in order to be able to do the replication. Press enter. We will then flush privileges. Okay, that's it for the creation of the user. We will do the same thing on the other side. So let me go ahead and do that. But before I press enter, let me grab the IP address for this box, 138. We're just keeping the username and password same to keep it simple. That's that, plus the privileges. All right. So now if we wanted to test MySQL minus h 192.168.88.138 minus u, the username is slave user minus p, and put in their password. Can't connect to MySQL server on blah blah blah. It sounds like we have the firewall running. And sure we do. So like I said, I'm just going to disable the firewall D for this tutorial on both sides. oops, systemctl stop firewall D is what I wanted to, but disable is fine for this machine. It'll be destroyed after the video is complete, so disable firewall D, just keeping the same state on both sides. All right, so now that we have the firewall disabled, let me try to do that again. And we get the access denied for a user. That's basically because we don't meet the requirement of SSL because we're not using the SSL to connect. What we could do is we could specify the SSL cert equals var lib mysql -search, and then say server, this is server B, server b.cert.pem, and then the SSL key is var lib mysql -search server b-key.pem. Oops, I need to specify the -p flag as well, or that password wouldn't work. Oh, you know what? We haven't configured the actual SSL on the CNF file, so the other server does not know what CA to use to authenticate. My bad. So let's go ahead and actually configure the SSL CA and other stuff in the MySQL CNF file. Back to the etc my.cnf.d server.cnf. Here we need to specify the SSL options. So SSL-ca is going to be path to var lib mysql -search, and the certificate name, if I can remember, is the MySQL ca-cert.pem is the SSL CA. Then we have the SSL-cert equals var lib mysql -search server a-cert.pem, and then SSL-key is var lib mysql -search server a-key.pem. Once again, give a little bit of space between these things here, just make it more readable. And that's it. grep -I SSL etc my.cnf.d server.conf CNF actually. Okay, now let's just make sure this file exists here. It does. This file does exist. This file does exist. So we have all the files in place. Now we're going to copy this over and do the same config on the other side. my.cnf.d ss server.cnf. On the SQL here, we paste it, and we're going to, because this is second server, we're going to say server B and do the same thing, SSL etc my.cnf.d and server.conf, and let's make sure everything is in place. That's there. And that's there. So everything is in place. So now one thing I want to show you real quick is MySQL. We can do so variables like %SSL%. So we see that the OpenSSL is disabled, the CA path, and everything else is blank. So that's good. I just wanted to show you that. Keep note of that. Let's go ahead and restart MariaDB to actually apply those changes on both sides. Systemctl restart MariaDB. While it does that, let's go in. And you see that it's loaded the path as specified in the CNF file, but we see that this is disabled, right? So that is probably disabled because of the Ssl Linux, and the MySQL is probably not able to access those files. Let me grep -ir SSL var log mariadb.log. So as we can see here, failed to set up SSL error, verify paths failed. So basically the Ssl did not allow the MySQL to access those files. Let's go ahead and also, if we look at the permissions, we do see that it is owned by root. So let's go ahead and change the chown -r MySQL :MySQL search. Make sure the permissions change. We do the same thing on the other side. I don't think this changing the permission alone is going to fix it, but let's just, for the purpose of this video, let's go ahead and apply that change, and we will check back again, make sure that doesn't work. If it works, great, but I don't think it will. So back to the server 1 here. So we still have the disabled, and probably if we still grep for SSL, we still have that error. So, and also checking the folder permissions for lib MySQL -search. We still have the MySQL, but it still doesn't work. We will just go ahead and disable the Ssl in order to keep this video simple. So set enforce 0 and get enforce. Okay, that's permissive. Set enforce, or yeah, set enforce to 0 and get enforce. That's permissive. So now let's go ahead and restart the MariaDB one more time. And okay. Now let's go back in there and look. So variables. So now we can see that the have open SSL and have SSL is both good. Let's validate here as well. Oh well, MySQL. So variables like %SSL%, and we can see it is enabled on this side as well. Now let's go ahead and do our test again. That's that, and let me grab the password. Where is my password? Just a second. And we are logged in. So now once we have the SSL parameters all configured on both sides, we're able to log in with the certificate and the key. So that validates our SSL to be working. Now let's go ahead and configure the actual replication on both sides. So we will start by creating the second server as the slave of first. So in order to do that, we will do the Ssl master status. So this file and the position are the two things of most importance here. So let's put that for the server A. We have the okay, so now we're going to issue the change master command on the second server to configure this as the slave of the first server. So say change master to master underscore host equals, we need to grab the IP address, which is 138. It needs to be inside the quotes. So we have that, comma, master underscore user is slave underscore user that we created. Master underscore password is going to be the password that we set earlier. Then we need the master underscore log underscore file equals. So the master log file is this guy here. So we set that, and then the next option is the master log underscore position, which is going to be 245 as said here. Since this is a number, we don't need the quotes around it. master underscore SSL equals 1, master underscore SSL underscore CA is going to be, let's see what the CA is. That's the CA. So put inside the quotes. That's that. Master underscore SSL underscore cert is the same thing but server B, because we're configuring the server B. So that, and we also need the key. So master underscore SSL underscore key, that's going to be that, and we finish our command. So now if we do the, let me actually clear this screen. Clear. So slave status. We can see that the slave is not running. Now let's go ahead and start slave start. And hopefully the slave is now running. So slave status. Okay. Looks like we messed up a little bit there, so we will stop the slave and stop slave. I needed to actually say server b-key, so that should fix the issue. Systemctl system clear. Okay, now start slave. So slave status. Okay, we have the MySQL Ca cert, we have the server B, we have the server key. Let me just validate real quick. I hope I had the right password. Nope, I had the wrong password apparently. So, let me go back in here, stop slave. Let me clear the screen so it comes at the top. And so let me update the password here. Okay. Okay, something is up here. I was able to log in a while ago, but not anymore. What does that mean? Okay, I must have. Okay, so there was a typo in my password, which is why I couldn't log in. I thought I had the password 1, but I apparently made a typo here. So that's the actual password. Okay, stop. Let me go ahead and clear screen again. Okay, and we need to actually stop the slave before we can make the change. So stop slave, and we are going to update the password with the correct password, and that's it. So now start slave, and it should work. So slave status helps when you have the correct password. So we can see that the slave IO is running and the slave SQL is running. Let's go ahead and do the same thing on the other side. System clear. So master status /g, and on this guy here we are going to system clear. And actually this is a long command, so let me actually copy that over. This. Okay, and then we'll make some quick changes here. So the IP address first. System 5 config. So this is the IP address the 140. Password should be fine, and then the server b-bin, and the number index seems to be correct. The position is 245. The location of the file, we just need to change the A and the B, and that should be it. Go ahead and run this. Okay, so slave status, slave is not running, system clear, start slave, so slave status. And we can see that the slave is now running. So we do have the master-master replication over SSL channels configured at this point. Let's just do some validations as we talked about earlier. In order to do the validation, let me just go ahead and create a database. Create database. You know what? First, so databases. So we see those are the databases, and so databases. Okay, I think at this point I can just go ahead and do that and do that. So I have both the things here. Okay. So we can see the SO databases. Now we'll go ahead and create the database validation on our first server. Now if we look at the SO databases, we can see that the database validation has been created. So now we will go ahead and use the validation database. Use validation. Okay. And system clear. So tables. Don't have any tables. System clear, so tables. Don't have any tables. So we'll go ahead and create a table now. So in order to do that, let me just copy this. So we created the users table. Now if we go, we see there's users table. Select star from users. We don't have anything. Select star from users. We don't have anything. So let me go ahead and clear both the screens. Okay, now what I'm going to do is insert into users. Username is values, and then testing validation 1. Okay, and then now if we go ahead and select start from users, we can see testing validation 1 over there. Let me go ahead and run this here, and I'm going to say 2. And we can see the 2 is on both the servers. So that kind of validates the replication is working, but is the replication working over the encrypted channels? So let me go ahead and install TCP dump on this box. Yes, we want it. And then TCP dump -i any port 3306. I know that nothing else is talking to this guy on the 3306 port. So when I insert this data, we will see the encrypted data over here. So as you can see here, the data is encrypted. When you have the replication over non-SSL channels, you will see the plain text data being passed over. So that's how you configure the master-master replication over SSL or the encrypted channels. Especially if you have your database servers separated over a larger geographic area, or even outside your data center, or even, you know, if it's inside your own data center, it's always a good idea to encrypt the data flowing over the wire, especially for the database. So I hope this video was really useful for you to understand the replication and, you know, how to configure the database replication over SSL channels. I really hope this video was useful. You liked this video. If you like this video, please like, share, and subscribe. And don't forget to hit the bell icon so that you are notified next time I publish my video. Please leave your comments, feedback, and likes in the section below, and I will see you in the next video. Thank you for watching.